Okay, now we're going to do a problem with a fractional exponent which isn't just a square root. So here we have the equation x plus 5 to the 3 halves plus 11 equals 19. Now, in order to solve this equation, eventually we're going to want to raise both sides to the 2/3 power because that would cancel this 3 halves. But we can't do that until x plus 5 to the 3 halves is completely by itself on one side of the equation. Only then can we raise it to the 2/3 power to cancel it. Okay, which means in this problem, the first step is to subtract 11 from both sides. When we do that, we get x plus 5 to the 3 halves equals 8. Alright, now we can raise both sides to the 2/3 power. The reason we do this is that when we have a power raised to another power, they multiply. So we picked the 2/3 power so that when we multiply these two numbers, we get 1. In other words, after this, we go to the next line, we see that x plus 5 is now all by itself. It doesn't have a power on it anymore because the 2/3 and the 3 halves canceled. Now, whatever we do to one side, we also have to do the other side. And so we have 8 to the 2/3 power as well. Now, to evaluate this, the bottom, the 3 here, says we take the cubed root, so we get 2 squared, which means finally we have x plus 5 equals 4, so x equals -1. Okay. But again, whenever you're doing a problem with fractional exponents, you must check your solution at the end. So up here, I've gone and plugged it back in, and I make sure to plug it back into the original equation. So we get -1 plus 5 is 4. Now it's 4 to the 3 halves power, which when we simplify, this says we take the square root, so we get 2 cubed. Finally, that simplifies to 8, and we see that 8 plus 11 equals 19. So -1 actually was a solution to the equation, so we were right.